What? Okay. So yesterday we were talking about area of a trapezoid. Yeah. Any questions about that? So remember, the formula is area equals 1/2 h v1 plus v2. And remember, it's possible sometimes you might not be given all that information explicitly. Let's just do one more example. Suppose it's something like this, where you have a right trapezoid. And let's say this was like 10 centimeters, and this is 16 centimeters. And that's all they gave you. Oh, wait, no. That can't be all they gave you. Suppose this was 60 degrees. That's all they gave you. So what's the trick here we do in all these types of problems? Yeah, chop off the triangle in the end. That gives you a rectangle and a triangle. So if that's 10, this is 10. And this ends up being a 30, 60, 90 triangle. So remember, if the hypotenuse is 16, what's the length of this short leg down here?
Is that half?
Yeah, it's half the hypotenuse, so this is 8. And then how's that related to this side over here? Yep, 8 radical 3. Yeah, so that's it, right? And then once you have all of those pieces, the area would just be 1/2 h. So it's 1/2 of 8 radical 3 times b1 plus b2, 10 plus 18. Okay, so this ends up being 1/2 of 8, which is 4 radical 3 times 28. So you can multiply the two terms that are outside the radical. 4 times 28 would be 112 radical 3. And the units would be square centimeters. Okay? Does that make sense? All right, so today we're going to talk about different geometry. Do we have a quiz tomorrow? Yeah, we do. Yeah, let's talk about that now. So there's a quiz tomorrow. And it's on everything we've done since the last quiz, which included area of a triangle, we did this 3 ways, remember. We did it using the basic formula, which is area equals 1/2 base times height. We did it using a coordinate grid. That's when the coordinates for the vertices, you graph the triangle, you enclose it in a rectangle, and you subtract the area you don't want. And then we did using Heron's formula.
Is this the IXL one?
Yep. So remember, Heron's formula is area equals square root of S times S minus A times S minus B times S minus C, where S is the semi-perimeter, add up the sides and divide by 2. Okay? And that's, oh no, we also did area of a parallelogram. So remember that formula was area equals base times height.
And that would fill the math.
I don't remember. Yeah, probably. Okay. Any questions on any of that stuff? That's for tomorrow's quiz. Thanks for asking.
You know, a problem on that Netherlands formula again. Problem on that Netherlands formula again.
You want me to do one of those? Sure, yeah. Okay. So remember, Heron's formula is used if you have all three sides of the triangle. So suppose you have a triangle that looks like this, and its side lengths are 2, 3, and 4. Okay? Well, this is going to end up being a decimal. That's right. All right, so the first thing you do is you calculate the semi-perimeter, which is half the perimeter. You take 2 plus 3 plus 4 divided by 2. And I just recognize this is going to be an odd number, but that's okay. So this is 9 divided by 2, which is 4.5. So the area is the square root of 4.5 times 4.5 minus 2 times 4.5 minus 3 times 4.5 minus 4. So if you simplify that, this is the square root of 4.5 times 2.5, that's 4.5 minus 2, times 1.5, that's about 4.5 minus 3, and times 0.5. That's 4.5 minus 4. And then you just do that on your calculator. That's it. So this would be square root of 4.5 times 2.5 times 1.5 times 0.5. And the square root's over that whole thing. That's it. So it's 2.9. If this was to the nearest tenth, then this is about 2.9. And remember, units are always squared. So if this was inches or whatever, if these were all inches, then this would be inches squared. Okay? Well. Bless you. Or anything else? Quiz. Okay, so today we're going to talk about area of a rhombus. What's a rhombus? You guys remember?
Like the two triangles, kind of like look out. Yeah.
Yeah, a diamond shape.
I want to do that.
Yeah. So in general, a rhombus is a quadrilateral, 4 sides, and it has all 4 congruent sides. That's all there is to it. So rhombus is any quadrilateral with 4 congruent sides. And when you draw it, it's helpful if you draw it like a diamond shape, rather than like so sitting on its point, rather than drawing it, trying to draw it like a parallelogram, like lying on one of its sides. The reason why it's better to draw it this way is because things that are true about it look more true if you draw it this way than if you draw it kind of on one of its sides. Okay, what's that?
And you can draw there.
Yeah, you can draw there. Everybody can draw. So, so there are certain properties of rhombuses. So the first thing is obviously 4 congruent sides. The second thing is it has 2 pairs of opposite congruent angles. Opposite angles are congruent. Another thing that's true about rhombuses is that the diagonals bisect each other. So that just means that if I draw in these diagonals, they each cut the other one in half. So like this is the same length as that. This is the same length as this. They bisect each other. The point of intersection of the diagonals is the midpoint of each diagonal. Okay? And then the last thing that's really important is that the diagonals are perpendicular. And this is something that looks obvious if you draw it this way, and it doesn't look obvious if you draw it sitting on one of its sides. It doesn't look like it needs to be true, but here it definitely does, because one of the diagonals is horizontal, and the other diagonal is vertical. So of course they're perpendicular to each other. Okay, so those are the most important properties of rhombuses. One more I think that's important is that the diagonals bisect the angles. Diagonals bisect the angles. This isn't true in a normal parallelogram. Like if I draw a parallelogram just like this, I mean, the diagonals definitely don't bisect the angles, right? I mean, that diagonal doesn't split this angle in half. That piece is definitely a bigger angle than that piece. But it's true for rhombuses, okay? This is not true. So not true for normal parallelograms. And I say normal parallelograms because actually a rhombus is a type of parallelogram. So I didn't want to say it's not true for parallelograms because it is true for some of them, like rhombuses. Okay, so these are the properties of a rhombus. So let's talk about area of a rhombus. So for any rhombus, area is equal to 1/2 d1 times d2. And d1 and d2 are the lengths of the diagonals. So if I draw a rhombus here, and I draw in both diagonals, okay, d1 would be the length of one of the diagonals, like this. d2 would be the length of the other diagonal, this. Of course, it also works that the area is base times height. I mean, it's a type of parallelogram. So that formula would definitely work if they happen to give you that information. But I can tell you, for rhombus, they're not going to give you that information. They're going to give you the lengths of the diagonals. Okay? So let's think about why this is true. Again, it's fairly obvious if you think about it the right way. So why is this true? If I have a rhombus like this, and I draw in the diagonals, I want to make sure that very rhombusific. I don't know if that's an adjective or not. Rhombific?
Rhombi.
What is that? Rhombi? Very rhomby. This looks very rhomby. What's that?
Rhombusy.
Rhombusy. I like that. So if you draw in the diagonals, you actually form 4 triangles that are congruent. And if I look at my picture up here, it's kind of obvious why they're congruent. Why are these triangles congruent?
The diagonal is split in half. How would you describe
There can be
all the
5.
sides?
What's that?
All the sides.
Yeah, side, side, side. There's 5 reasons why triangles can be congruent. Side, 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 angle, side, angle, 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 side, and HL. Those are the 5 reasons, right? You could actually use any of those 5 reasons here, but the most obvious from that picture is side, 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 right? We can also use HL, right? We have a right triangle, there's the hypotenuse, and there's a leg congruent to the hypotenuse and a leg. So we could use that. Or we could use side, side, or we could use angle, side, angle, or whatever. There's lots of, any of these methods would work, right? But anyway, the point is there's 4 congruent triangles. So what you could do is you could take like one of these triangles, like say this one right here, and just take it out of the picture and glue it on right here, like that. And it would fit perfectly, right? And the same thing goes for this triangle. I could take this triangle and take it out of the picture and glue it on over here. And it would fit perfectly. And what you'd end up with is this rectangle right here. Right? And it should make sense that the area of that rectangle is exactly the same as the area of the original rhombus, because it's the same 4 triangles just put together in a different way. But if you look at this rectangle, this length of the rectangle is D2. And this length of the rectangle is 1/2 of D1. It's half of the length of the diagonal going this way. So the area of the rectangle would be 1/2 of D1 times D2. That's exactly the same as the area of the rhombus. Okay, so that's why the formula is what it is. It's 1/2 D1 D2. So sometimes they'll give you this information straight up, like they'll give you a rhombus. Maybe let's draw it this way. A rhombus like this, and maybe they'll just give you the length. Like they have to indicate it's a rhombus somehow, so that's how I'm indicating it's a rhombus. They might just give you these lengths. Like they might just say, this is 10 meters, and this is 4 meters. In which case, the area would be 1/2 10 times 4. And it doesn't matter if you switch the 10 and the 4. Multiplication is commutative. It doesn't matter which one's D1 and which one's D2. Doesn't matter at all. This is just half of 40, so the answer is 20 square meters. Super easy. Sometimes they might try and fool you, but not very well. You won't fall for it. Like this. They might draw in the diagonals. And maybe they'll say, this tall diagonal is 12 inches. And this distance is 2 inches. Right there. Not very much there. So it's hard to tell what I mean by that. I'm talking about this little piece right here, 2 inches. So here's where you have to use the properties of rhombuses, right? We know that the diagonals bisect each other. So if this piece of that diagonal is 2, then this piece is also 2, right? So this is also 2. So you'd say area is 1/2 D1 D2, which is 4, the whole diagonal, times 12. Half of 4 times 12, that's half of 48. So the answer would be 24 square inches. So that's not very tricky. Okay. So you can imagine another thing they might do is require you to use the right triangleness of the little triangles, okay? So for example, they might give you something like this, where they say, here's a rhombus, they'll draw in the diagonals, and maybe they'll say, this is 10 centimeters, and this piece right here is 8 centimeters. The 10 refers to the length of sides. So what do you do here?
I would have a base on height. No, not height.
Well, you have one of the diagonal on the side.
Yeah, okay, so I agree, this is 8. But to find the area of the rhombus, you need both diagonals. So we need this
have
like,
to do what the thing where the height is. I don't remember exactly how it works. But the height of it is. Well, we did this in a question like this.
I kind of gave you a hint when I was drawing it. I said we're going to use the right triangleness of this, right? These are right triangles. So when you think right triangles, you should think, well, 3 things can be true. Trig, like trig works with right triangles. Pythagorean theorem works for right triangles. And it might be a special right triangle, like a 30, 60, 90, or 45, 45, 90. Those are the 3 important things about right triangles. Which of those do you think applies here? Pythagorean theorem, right? This is actually a 6, 8, 10 triangle. But if you didn't remember that, like just label this piece like x or something. You could do x squared plus 8 squared equals 10 squared. And then just solve. You end up with x equals 6. Okay, so this is 6, this is 6. So now we can do it. The area is 1/2 d1, d2. d1 would be like this diagonal 12. d2 would be like this diagonal 16. So this ends up being 6 times 16, which is 96 square centimeters. Okay? Or you might have a triangle that, not a triangle, a rhombus that requires you to use trig, right? So maybe you have something like this. This is, drawing the diagonals again. Maybe they'll tell you this is 60 degrees. Okay, and maybe the only length that they'll give you here is, this is 5 feet. So this is a special triangle, right? If this is 5, that means this is 10. And what's the length of this long leg here? Yeah, 5 radical 3. This is also 5 radical 3. This is also 5. So now we have everything we need. We didn't really need the 10. I was just kind of reviewing that. Remember. Okay, all we really need is the lengths of the diagonals. So the area here would be 1/2 d1, d2. d1, let's have that be the short diagonal, so it's 10. d2, what's the length of this long diagonal if you add up those 2 pieces? Yeah, 10 radical 3. You take 5 radical 3 plus 5 radical 3, you get 10 radical 3. So this ends up being 50 radical 3. Half of 100 radical 3 is 50 radical 3 square feet. Let's do one more example. How about if this was something like this? Let's say this was 45, and this is, let's say this was like 2. What's the deal here?
8 times 5. Is that half 8 times 5?
What do you mean?
That is 45 the angle.
45 is the angle.
Oh, okay.
Yeah, sorry. What'd you say?
It's like 45, 45.
Yeah, so if this is 2, what's this? No? This is 45. This is 2, what's this? I can't hear. 2, yeah. So here, the area would be 1/2 D1, D2. Half of 16, the answer is B, square units. Okay? So you gotta figure out the lengths of the diagonals, whether that requires you to use trigonometry or Pythagorean theorem or special triangles or whatever. You need the lengths of the diagonals before you can apply this formula. Any questions? Okay, so the homework is on IXL again. IXL, area of rhombuses.